clicking here. So this is now the assembly is made of individual components with the help of solid edge. Now think about some other constraint. It is allowed to move in Z direction up to the distance. Say we select some distance, any distance could be selected to draw its exploded view, and select active parts only. This one in Z direction, the movement, say this much degree, angle is selected. It is up to you whichever distance to be select. Here 0 degree is selected so that no axial misalignment is allowed. It can travel or it can move in X direction or in Z direction only. So this is the detail of plumber block which we have seen. The block front view, the dimensions are inserted over here, and this is the top view of plumber block with the details. First component, and this is the second component. One more component, the top face of the plumber block, front view, and this is the top view of the upper surface of the plumber block, and this is the one view of that bolt which was inserted. 2 nuts, 2 bolts and 2 lock nuts are there. So it shows the assembly of lock nut and bolt having given different dimensions. So this shows the detailed drawing of each components of that plumber block, and this shows the assembly of plumber block. If we assemble all the components together as we have seen in the animation, this would be the assembly drawing of plumber block. Here also it's not needed to insert all the dimensions in this assembly, only some important dimensions could be added. Now detailed drawings, what does it shows? A detailed drawing is a combination of an assembly view with several of its parts depicted as dimensioned multi-view drawings on one drawing sheet. That is the definition of detailed drawing. And this practice, though not common, reduces the number of drawing sheets needed and is more appropriate for designs with small numbers of components. Assembly of screw jack. As we have seen the animation of screw jack, let we skip that animation and we draw sub-assembly drawings. Now what do you mean by sub-assembly drawing? This is one live example of a torch. Large or complex assembly may be communicated through sub-assembly drawings. This is the assembly drawing of torch, and this is orthographic view of flashlight sub-assembly. Here you can see this is a line diagram of flashlight sub-assembly. It is the colored view of flashlight sub-assembly. So this is the detailed drawing or the sub-assembly drawing of the torch light. Now assembly of engine cylinder, how it works and how it is assembled together. Let me see the engine cylinder assembly with one animation. Here each parts are called one by one. Open. This is the shaft which is called over here. This is the shaft balance which is called here. And to make this assembly, let me select this surface. This is the taper surface, so both could be inserted like this. Let me accelerate this video. Both the parts are assembled together like this. Could be like this also. Now insert this shaft, select this one and this surface, outer surface of this shaft, inner surface of this hole, both are selected and made together. If you click here, it will make an assembly of this shaft. It's a flip command which is used to select both the views. Let me make, this is an assembly of crankshaft and connecting rod. Big end of the connecting rod is this one. Now we call here some more components. Say piston. This is the piston which is inserted over here in the small end of the connecting rod like this. So this allows the axial movement of the connecting rod or oscillatory movement of connecting rod. Because the connecting rod has to oscillate, the piston has to have linear movement and crankshaft has to rotate in rotary direction. So this is the gudgeon pin which is inserted in the small end of the connecting rod, this one, and this gudgeon pin, this piston and small end of the connecting rod needs to be assembled like this. So for that, select this surface, select this inner surface. So with the selection of these two surfaces, they have met each other. So this is the assembly of piston cylinder assembly in IC engine internal assembly, which allows the linear movement of piston and oscillatory movement of connecting rod and rotary movement of the crankshaft to transmit the torque from piston head to the crankshaft rotation. Now this is a pictorial assembly, example of pictorial assembly, usually depicted as an isometric or perspective drawing, may be rendered to imitate photographic quality. Here this is one pictorial assembly. It is used for three types: maintenance procedure, for customer self assembly and sales promotions. This kind of pictorial assembly is widely used. Now this is one more example of pictorial assembly. This one. These pictorial assemblies are often used in catalogs, journal articles and advertisements as well. You might have seen such kind of pictorial assemblies. This pictorial is sectioned to show interior details. Now pictorial assembly drawings. This is one exploded pictorial assembly drawings which is commonly used to show how individual components fit together. You can see these are the components numbered from 1 to 12. Names are mentioned in the part list, and this shows the pictorial assembly drawing having exploded view of each components showing their relative positions. Now assembly of motor vehicle. Let me see assembly of motor vehicle, how it is assembled together. So that is regarding the animation of assembly of motor vehicle. This shows the detailed drawing of tool post. Various elements are there. Number 1, this component number 1 is the pillar. This one, 2 views are there. Number 2 is a block. This one. Number 3 is a ring. This is the ring. Number 4 is a wedge. This one. And number 5 is a screw. This is the screw. Now to make the assembly of all these components, let me imagine how they should be assembled together. So for that, first you can see here threads are there. So this internal thread and these external threads are of same dimension, so we can assemble them together. Here wedge shape, circular shape is there. Here also circular shape is there. So it could be assembled together. And this is the assembly of tool post assembly, having 2 views. 5 components are there, namely 1, 2, 3, 4 and 5, shown with the balloons. This is the square tool post details, which is also asked the numbers of times in the examination. And this is the isometric model of square tool post. This is also a square tool post which is drawn with the modeling software. This is the assembly of connecting rod, made up of small end, big end of the rod, brass, bushings, nuts, bolts and small end brass. Detailed drawing of the connecting rod, more details of the bolts, set screws and brasses of the connecting rod. These are the websites through which you can download various details of various valves and eccentrics, pulleys, sockets and spigots. These are the websites through which teaching material is available to us. So I hope today's discussion was fruitful to you. You might have learned some new aspects as far as the detailed drawing and assembly drawing is concerned. You would be able to grasp some of the basic concepts which are used in the industry. Now onwards, in the next time we will continue with the new aspects, new topics, new discussions, and do take good care of yourself. We'll meet again soon. Jai Hind.